And good morning, everybody. Thank you for joining us for our webinar, Expand the Scope of Simulation through Simulia Technology as a complement to SOLIDWORKS Simulation. Our webinar will be 1 hour long. We will have a Q&A session at the end, so if you come across any questions during our presentation, please ask us, and we will be happy to answer those questions. I'd like to get started with a brief introduction to our presenter, but before I do that, I just wanted to point out to you a few names of interest. So Subhadeep Maiti is going to be presenting today, but we have also the contact information of our Simulation Services Director, Srikanth Srigiraju, and also of our VP of Advanced Engineering, Dr. Arvindam Chakraborty. So now to our presenter. Today, a VIAS introduction will be given by Subhadeep Maiti, Senior Simulation Engineer at VIAS. Subhadeep is a mechanical engineer with over 7 years of industrial experience in the field of design and numerical analysis of multiple industry products. He got his master's degree in mechanical systems design from IIT Kharagpur. Prior to VIAS, he was with Dassault Systems for almost 3 years as a Simulia technical specialist. He has extensive experience in solving linear, nonlinear engineering problems with focus on contact and convergence-related issues. Advanced explicit methodologies such as CEL, SPH, TEM methodologies, parametric, non-parametric optimization, and automation through EyeSight and Tosca. His expertise is in design and analysis of new products and processes using numerical simulation techniques with solid mechanics and design, rotodynamics, NVH analysis and experimental testing, manufacturing process simulation, reliability study and optimization, and fatigue life calculation. Now we will get started with our presentation. Subhadeep, would you like to take over?
Yeah, sure. Thank you, Beatrice, for the nice introduction. Uh, Good morning, you all, for attending this webinar today. So this webinar is mostly a very introductory webinar, I'll say. So there is the topics is I've chosen basically keeping in mind the design engineer, and I will not go much deeper into the simulation side. But what I'll show here is that how we can complement your SOLIDWORKS simulation by using some other existing simulation technologies or different class of problem which cannot be simulated through SOLIDWORKS simulation probably. So the content of my webinar today is like we'll be starting with a short introduction of a company, and then why I have chosen this particular topic. So there is a basic motivation behind that. So I'll talk about that. Then I'll be discussing about what is the existing SOLIDWORKS simulation technology for the state of the art design. Then I'll be discussing a little bit about the pros and cons of SOLIDWORKS simulation, and then we'll be going to the complementary solution which is offered by the Simulia. So it's basically how we extend the SOLIDWORKS simulation capability to Simulia power of the portfolio. And then I'll be discussing and showing you few videos like how you can directly transfer your SOLIDWORKS model to other different simulation software or solutions to do further advanced simulations. And then we'll be discussing a little bit about the design and optimization, and in this domain what kind of solution is available from Simulia side, and that will be followed up by question and answer session. So feel free to send any questions to us. It could be any technical or any general query, and I'll be happy to give you the answer on that. Okay. So let me just present a brief overview of our company. Our company name is Virtual Integrated Analytics Solutions, and we shortly call it like VIAS. And we started our company at Houston, Texas in USA with offices all over USA like Chicago, Cincinnati, San Francisco, Canada. And recently we have opened an office in India as well. So we are a value solution partner of Dassault System. That means that we can sell different these solutions to the end user based on their requirement, and we are a platinum partner. Also, we have a strong team with multiple industry experience catered to industries like oil and gas, high-tech equipments, petrochemical and process, nuclear industry, aerospace, medical device, and consumer goods, transportation, mobility. So when we look into the end user problems, we try to bring the best practices from multiple industry experience, which results in optimizing the simulation model. Also, it helps us to push process and take the correct decision for the accuracy and betterment of the product. And our team consists of PhD and masters in different domains like solid mechanics, fluid mechanics, material and corrosion, civil structural, numerical analysis, data analytics, and optimization and reliability. Also, we do have a dedicated team who provide the engineering and PLM consulting service. We provide trainings on the simulation side. Also, we provide the software sales and support, which I have already discussed. And also, we can do lot many automation and customization through scripting for a guided workflow development. So here is our technical capabilities. So I have just listed few of them. So starting from the component design and validation to the digital mock-up development and system engineering, we are in all phases of the design, uh, creation, and the validation process. So we also provide uh, a we also provide consulting service in the different advanced simulation domain, which are generally not touched by the normal users, like FEV's fracture or damage mechanics, and then like engineering critical analysis, then design optimization. So these optimization are not like very standard optimization. So these are mostly like in advanced domain where your optimization can have non-linearity and it can have multiple peaks and valley, and even you can do different kind of manufacturing simulation reliability study as well for different parameter combination. Also, we provide our expert knowledge in the structural analysis and vibration assessment domain. So we are having people who are having years of experience in the real world testing and experimentation, and also in the FEA simulation correlation process. So especially in the vibration domain, if you know, so because the loading is unknown, so the correlation is really a difficult part over here. But our expert team can help you in having that correlation and standardizing your workflow or work process. Also, we have a team who provide the solution in the electromagnetic systems, design, simulation, and optimization of different antenna and electrical devices. Also, we are having a dedicated team who do the competition fluid dynamics, flow analysis, and thermal analysis kind of solutions. And we also have a team of experts who have a years of extensive experience in the fatigue analysis domain. It could be like high stress or the high cycle or the low cycle stress analysis. Starting from that one, we can provide the consulting on the complicated product like a rubber, plastic, or say oil kind of material, where or the clip kind of scenario where the fatigue is really complicated, and the background here is really very much complicated, and it is not very easy to understand. So in that area also we are having expert who can provide great understanding of the fatigue life calculation. Also, we have a dedicated team and experts in the composite modeling analysis, and definitely maximum people in our team know the simulation automation part through different kind of scripting. So we are adding value to different customer through different ways. So we provide consulting service, and to name few of the companies like Delphi, Sale, Polyone, and Kinder Morgan, etc. Also, our consultancy in the CFD domain is something like ExxonMobil, and then Copin, then Vico, etc. And in the data analytics domain, we are providing consultancy in the Samsung, Gap, and Nasha, etc. And as a DS value solution partner, we are also eligible to sell the different they sell product to the end user, and few of the customer who are having solution from us is like Hutchinson, then VAM USA, Hunting, etc. And we provide training to a lot many customer, and the training could be like either on-site training or it could be the in-house training. And we are a training partner of Airbus and Boeing, so we regularly provide training to their end user. Also, we have provided training, and we are providing training regularly to the different companies like Schlumberger, Shell, Ambitech, etc. So as a value solution partner, so the kind of value we are going to add is like we are committed to every client's success, to the technical excellence innovation. So here we don't wait for the customer to come back to us with the problem. So we always try to get engaged with them and find out where is the difficulty they are facing, and based on that we provide our experts opinion or the solution, so that they can address their problem at the early phase of the design iterations. Also, we have domain knowledge in FE and expertization in the multiple industry experience, and that adds a lot many value to the customer, especially in the simulation model development or the workflow process development. This multiple industry experience really add to create a best-in-class simulation methodology. We can also review your existing simulation workflow if you are doing right now, even the processes. Also, you can provide a feedback like if you need any enhancement for the speed, usability, and the accuracy wise as well. We provide the customized and standard training in-house, on-site, and online. Also, we offer software development services for Abaqus, including user subroutine, user element, Python scripting, allowing the pre and post processing features and calculation. So this is in a balance like what is the value you are going to add to the customer. So if you are having any requirement in the training side or in the um, customization side or in the consultancy side, so please contact us. We will be happy to help you in that regard. So now I'll be going to the actual heart of the topic today. So what is the motivation of this particular webinar? So this is a simple workflow, typical development process for a for a typical product development scenario. So the product requirement definition of our CAD design and based on experience. So the typical development process basically goes from a product requirement definition of our CAD design and based on experience, and then to virtual testing to simulation. Because of the interaction between the component, there is a couple of loops necessary until having a design which fulfills the requirement, which goes then to the prototyping and testing and the final validation. Finally, the start of the production follows. As you all know, the chosen design has a major influence on the overall performance as well as the cost from the single component of a subsystem, the system up to the whole car as well. So here uh, the motivation what we are saying is that the traditional method of having a separate simulation department is generally inefficient. So generally normal industries don't use the simulation in the early phases. So by the simulation is done, the design has evolved. So some companies are having their dedicated simulation team, but when they are doing the simulation, but the design is already been decided. So the analysts only make the decision like they give some design recommendation that may violate the design intent or cannot be manufactured. So 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 the main idea over here is that if the designer is going to do the simulation, so then what will happen is that they can take the decision at the early phase of the design, and that will definitely reduce the escalation cost. And 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 a fundamental fact is that behind our initiative to provide powerful simulation to designer is that the later in the product life cycle a design change is made, the more costly the change is. The cost of a change grows exponentially with time. So the key to business success is to like identify any product deficiencies as early as in the design process as possible. But we have known that for years, why have no designers has been doing the simulation before now? So uh, So in January 2015, SOLIDWORKS Initiative was established with the mission to promote the use of simulation by the SOLIDWORKS designer. And the key difference between a simulation expert and a designer is that the expert uses the tool on a full-time basis, whereas the designer uses the tool on a periodic basis for basic functional simulation functionality. And the designer has basically two special needs. One is like greater demand for easy of use and minimal training requirement, and also the price that reflects the periodic use. So the first step for many SOLIDWORKS customers to use simulation and should be to use SOLIDWORKS simulation. But once they are mature in their use of simulation and need more advanced simulation capability, then they may adopt advanced simulation solution like Simulia solution. So from 1978, Simulia has focused on developing the software for use of simulation expert. So here, the Simulia tool could be really helpful uh, for doing the advanced kind of simulation. So in SolidWorks simulation, the typical capability is that so this slide shows a different kind of design process where the simulation and optimization is playing a role. So as a new topic on the product requirement, we can now find that the design space definition, which is a first step for a design concept optimization and created by topological optimization, and and which already includes constant for functional manufacturing requirement. And the next step is then is to use extensive virtual testing, including finite element analysis, fatigue analysis, multi-body simulation, or further optimization for the fine-tuning of the optimized design concept. And after that, you basically get a final CAD design, followed by prototyping, testing, and final validation before the production start. So this process gives a chance to get quite close to a really good design. So until now, so designer is following until this process. So that is quite good now. So SolidWorks really provide a great set of tools to until this phase. But there is certain pros and cons of SolidWorks simulation. So we are going to discuss about that one in the later slide. So the SolidWorks simulation capabilities are bundled like this. So they can do a simple part or assembly analysis to FEA, like you can do a simple kinematic motion analysis. You can do the train taker. That means if you're changing a certain design variable, what is the response, how the response is changing. Also, you can do metal fatigue analysis. It's only scattered to the metal fatigue analysis, not to the advanced kind of material like hyperelastic material or say weld material or say grip kind of scenario. Also, it is having a standard model for drop test analysis and frequency domain analysis, like say random vibration analysis or say frequency extraction, natural frequency calculation, etc. Also, it is having a basic design optimization capability, and it is having its own material portal. So if you're having access to that one, so you can really pull the standard material properties from the material portal. And also it is having some capability to decide that what is well size required based on different kind of standard code like BS code or SI code like that. And also it can offer you like simple thermal structure analysis and some modeling simulations. But but if you compare the simulations, what other kind of simulations is possible, so you can see there is a whole branch of other kind of simulation which is not available in the SolidWorks. So those are like if you want to do a post buckling analysis or quasi-static analysis. I think quasi-static analysis is available in the SolidWorks, but that is very basic. So there are other kind of application in the quasi-static analysis, like if you are having a certain part which is in the space and there is no damping. So in that case, the kind of quasi-static application is quite different, which is not available in the SolidWorks. Also, direct cyclic analysis, where you can apply cyclic loading to find out like the fatigue life, and it is not having this low cyclic fatigue calculation, and it doesn't offer the direct steady state dynamic analysis. So all dynamic analysis is basically based on a model dynamic procedure. it can't find out the complex eigenvalue extraction. So if there is certain part which are connected by friction, so friction actually create an unsymmetric matrix. So in that case, the natural frequency changes because of the damping and the contact friction. So they are the complex eigenvalue really is useful to decide what will be the dynamic response of the system, and this is especially useful for the tire domain. Also, it is not having the response spectrum analysis, and it is not having the fully coupled thermal stress analysis and the adiabatic analysis. And here are the few additional things which are in the advanced area, like substructure analysis, steady state transport analysis, coupled fluid flow analysis, annealing, or different kind of multiphysics analysis like electromagnetic analysis. So if you're having a fuse and if you're passing current to the fuse, because of electrical current, there will be heat generation and it will be having a structural changes. The fuse can melt. So their multi physics is basically combined together in the same problem. So those kind of advanced simulation you can't do, but it is having certain kind of other simulation tool set like topology study, design study, or pressure vessels design or fatigue analysis available for the designer side, not very advanced side, but for the designer this is okay what they are having right now. So what we are proposing is that, so when your product is different, so when you are having a product where your material is not metallic, it is having a highly nonlinear behavior, or even if you're having contacts which are highly nonlinear contact, so they can come into contact, they can be separated, or they can have friction working in between, and they can have a certain kind of penetration. So for advanced kind of context scenario or advanced nonlinear problem, the SOLIDWORKS is lacking in that scenario. So the experts who are using the SOLIDWORKS simulation, they probably know how they struggle when they are introducing a lot many contexts in the model, which are like the frictional kind of context scenario. So here the Simulia power of the portfolio really offers a great set of tools with the single licensing system. So the first set of tools is Abaqus. So Abaqus is basically started in 1978, and since then it is the industry leader in the nonlinear simulation, and it offers uh, five different kind of sorry four different kind of module, standard module which is like Abaqus CAE, then Abaqus standard, Abaqus explicit, and Abaqus CFD, and it is having advanced simulation capability like CEL, like coupled Eulerian Lagrangian method, where you can really model the fluid flow in the structural analysis system without going to the CFD scenario. And even you can have a FSI simulation, like you can do a fluid structural interaction, or the SPH method where your deformation of the part is quite significant, like say a bar is impacting a aeroplane blade. So in that case the bar almost is behave like a fluid when it is impacting on the on the aeroplane blade. Okay, so in that case you can model the bar with SPH, even you can model the fluid with the SPH elements as well, and it is having the basic electromagnetics capability as well. And then the next set of tool is the eyesight. So eyesight is mostly in the automation side. So in industry, when you are having multiple tools we are working with, so if you want to combine the multiple tools in one template or in one workflow so that the data transfer happens automatically, so in that case eyesight plays a good role. And not only that, eyesight is having a very good set of tools for doing different kind of parametric optimization and the DOE study or the reliability study. So if you want to find out like which particular parameter is having greater contribution to the final response of the system, and so you can change that parameter to the DOE table, and then you can find out that which parameter is having the higher influence on that. And generally these DOE technique are automatically created based on the different kind of techniques available. And also even when you are manufacturing certain product, due to the manufacturing constant, a certain product will not have exact dimension. So in that case, reliability study plays a good role, like Monte Carlo simulation or Six Sigma analysis. And Tosca is another set of tool which is available with the same licensing token, which is like Tosca structure and Tosca fluid. So these are basically having a great role in doing the non-parametric optimization when you cannot parameterize your part by using certain set of parameters. So generally those products are created either through molding process or through casting process kind of scenario. And FSF is definitely industry leader in doing the multi-axial fatigue analysis. You can do high cycle fatigue analysis, low cycle fatigue analysis. Individual is there which can help you to predict the complex fatigue behavior of the hyperelastic material. Then Verity is there, which is for a is insensitive well fatigue life calculation. And there are s- additional products available in the FSF as add-on for different kind of complex material scenario. So Abaqus is the world leading technology suite for finite element analysis software, and this is just a little bit small overview of Abaqus I'm going to show you. So this is a realistic simulation with finite element analysis for the multiphysics problem, and it is having a complete solution for a vast spectrum of industrial experience, starting from simple standard analysis like static analysis to a very advanced kind of analysis. It could be like CL, SPH, explicit analysis, etc. Also, Abacus is really great in defining complex kind of material behavior. So as you switch from metal to other kind of material, like say fluid kind of material, or say hyperelastic material, or certain kind of material like say gel or glue, okay, or tire. So there are a whole lot of advanced material which cannot be really characterized by using them with the material behavior what we use for the normal metallic structure. So to model those kind of complex material behavior, including the damage creation and the damage propagation. So Abacus really is having a great set of material library for doing that. Also, it provided rapid turnaround with high performance computing system. So once you are doing advanced simulation, generally the problem size grows bigger. So to solve those kind of problem, you can use some HPC, high performance computing system, to solve the problem in multiple cores. So the HPC automatically takes care of distributing the job to multiple cores. And then the next set of tool is eyesight. So I have told you previously, so this is just to automate different kind of industry solutions altogether in a template. So the data flow happen automatically, like say you're having different department in your organization. Someone is doing the testing, someone is doing the design, and someone doing the simulation. So they are doing independently, but this automation workflow, what it happen is that once they gather all those data and upload in this particular software, the data transfer happens automatically. You need not to wait for the email exchange or other things to get the data. So the data workflow will be automatically available like that. Also, it's not only that, it provides the design of experimentable data matching, which is a very great tool set. Like so I'll be discussing about the data matching in later slide as well. Also, it can do the approximation and the reliability study, and it can do the parametric optimization and the SGI kind of scenario, like the stochastic design improvement scenario as well. And Tosca is a non-parametric optimization solution, and Tosca is mainly having four different kind of suite. So I'll be showing that on the later slide. But here the idea is that you start your design by choosing a design space, and then you apply your loading and boundary conditions, and you decide a particular kind of optimization criteria, like you want to reduce your mass by achieving a certain amount of stress, or you want to have a certain kind of frequency response by minimizing the mass. All this kind of scenario is basically you're having a optimization task and you're having certain constraint on the design. And not only that, so once you have those kind of optimization problem, generally the kind of final product you get is something which is not manufacturable. So there you can apply different kind of manufacturing constraint, like is it going to be manufactured by casting or through drawing or through extrusion process. So by giving those manufacturing constraints, you can really get a part which will be having the optimized design with minimum mass and and the I mean it's optimum response. At the same time, that particular design will be manufactured, that can be manufacturable by a particular kind of manufacturing process as well. And in the similar note, Tosca is having a suite of Tosca fluid where you can optimize your fluid flow path as well. And now it's FESAP. So FESAP is primarily the fatigue analysis software, and this is the first software which basically introduces the multi-axial fatigue calculation. So generally, so when you are having a static loading, so the maximum product in real life does not fail under the static loading, and if that fails, that is generally a catastrophic failure. But when your product is having repetitive loading in its life cycle, the product tends to fail uh, well below its yield strength. Okay, so in that case, the fatigue calculation is really helpful. So generally, people in the industry, they use the metal fatigue calculation based on some mean stress criteria like the Soderbergh criteria, Goodman criteria, or Gerber criteria. But those are not really very accurate, and I'll tell you the reason behind that, and I'll show you several examples for that one. Okay, so generally we understand that if we are doing a FEA analysis for a particular kind of loading scenario, and if we are getting a maximum principal stress at a certain location to be high, and our observation from this mean stress based fatigue calculation is that that is the location where the failure is going to start. But that is really not true. So this is just one side in history. So let me give you an example of that one in the latter slide, where I'll be showing that uh, the location where the maximum stress is happening, there the failure is not happening. It depends on a lot many other factors as well. So FECM is the industry leader in capturing all those scenarios, and and definitely it will give you much better understanding of your product. Uh, so for getting a much better design in the initial design phase itself. Now, when you are doing a SOLIDWORKS analysis, SOLIDWORKS simulation for a product, so you basically start with a very simple design, and generally the mixing is like automated, and and the- and basically you are trying to uh, assume that maximum of the things are linear. Okay, like the material response will be almost like linear, elastic, plastic, or the 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 deformation is like linear, and also you assume that the contact is also like bonded contact, or like or like I mean to say no separation contact like that. but but that is really does not give the better understanding of the product. So that would be useful in the initial phase, but if you want to gain confidence on your product, so you need to do further additional study on the with the advanced simulation capabilities. So once you are having a SOLIDWORKS model which we have simulated through the SOLIDWORKS simulation, so you can bring that model directly to the Abaqus CAE using a associative interface without losing any data. So the process is that it maintains a relationship between the SOLIDWORKS and Abaqus CAE assemblies, and it enables a seamless geometry transfer or update. So if you click once in the SOLIDWORKS, the geometry will be automatically transferred to the Abaqus CAE. And if you rework on the geometry in the SOLIDWORKS, then the changes will be automatically propagated to the Abaqus CAE without any loss of the analysis feature. So this is like a SOLIDWORKS model. With a one click, you can directly bring the whole assembly to the Abaqus CAE. So this is a short video which basically shows you like how you basically bring the SolidWorks model directly to the Abaqus CAE. So in the left hand side, you see that we are having a connecting rod which is modeled in the Abaqus CAE, and the connecting rod is having several parts assembled together to bolt and nuts and other parts. Okay, so what you generally do is that you basically go to Abaqus C assembly module and then you assign a port, so that through that port the communication will be happening to the SolidWorks and Abaqus C. So once you auto assign a port, and then in the SolidWorks, if you directly say export to Abaqus C, and all the whole assembly will be directly exported to the Abaqus C. So you can see like in a single click, the whole model will be now transport will be imported to the Abaqus C without any data loss. So once you click OK, and you see the model is getting transferred to the Abaqus C. Okay. Now what you do is that you basically try to set up your model in Abaqus C, like you apply certain material properties, and then you apply certain loads and boundary condition, and you try to simulate that one. And even for the I mean to say for doing different kind of navigation to Abaqus C, you can have the similar kind of mouse setting like SolidWorks. You can set in Abaqus C, and here they are having a material property and they are having a section assignment. They are partitioning this top portion to apply a bearing load on the top location, like a pressure load here. And they are applying a fixity boundary condition at the other end. Now what they do is that they basically simulate this particular product. But here one thing you find out, like you can do the same thing in the SolidWorks engine. So why Abaqus say? The reason behind that is that if you see the actual assembly, this is having multiple parts connected together, and they are really having different kind of friction behavior, and contact is really difficult because there is threads and other things involved, and you really can't capture those frictional contact or the highly nonlinear contacting behavior using the SolidWorks simulation. SolidWorks will be able to do certain to a certain extent, but it will be struggling a lot to solve this kind of problem. So Abaqus is well known to solve this kind of advanced contact problem, and it will give you very accurate result. And after that, what you have done is that you basically define everything, loading, boundary condition, everything, and you got a result. And you find that the result is okay, but you think like it could be improved in a much better way. So now what you do is that you are changing the part in the SolidWorks. Okay, so you are basically changing this cart extrude parameter, and you are bringing this whole now. Now, what you do is that with these changes, you want to bring this particular model to Abaqus CA. Now, if you bring it, you see like in one click, the whole changes is been imported over here. And the best part over here is that whatever the loading, boundary condition, section assignment, or the task you have done in the Abaqus C, so those things are maintained. They are not changing here. So you need not to redefine everything altogether. So this is the advantage of having a seamless geometry transfer, and I believe this is quite interesting, and really you can have a better understanding of your product with the advanced capability of Abaqus apart from the SolidWorks simulation. Now, so few of the capabilities, like you can import the parts and assembly of the from the SolidWorks directly uh, without rearranging them for the whole assembly creation. So you can even export the solid surface or the wireframe geometry as well. So there is options for that one. Generally, the by default solid will be exported, and the automatic transfer of the part colors will be there. So in SolidWorks, so whatever the part color you are having, so the same color will be assigned in the Abaqus CA as well. You can suppress or resume the state update, and that thing will be reflected in the Abaqus CA, and you can change the position of the part and orientation of the part in SolidWorks, and same thing will be reflected in the Abaqus CAE, and definitely a geometric feature modification will be available in the Abaqus CAE when you're transferring from Abaqus SolidWorks. So after import, further changes made in SolidWorks are propagated into Abaqus CAE while retaining the previously created Abaqus CAE set surface or the analysis feature. Also, the interface packaging, like it's require a separate SolidWorks associative license for Abaqus CAE, but no special license is needed for the SolidWorks. So SolidWorks plugin is developed and released by Simulia. So once you are having the normal Abaqus CAE token, so with that one you can access this feature. You need not to buy any additional license. It was actually a separate add-on license, but you need not to buy it. It is available by default actually. Now I'll be going through different kind of additional simulation capability which cannot be done to the SolidWorks. Okay, so yeah, so in some cases there is a need to do a more complex situation, like you are having a large complex model, and and that is having huge nonlinearity involved in that, or you want to have a high performance computing, leveraging multiple cores, like uh, so if you're having huge number of nodes, or if your model is very big and if you want to capture the stress or strain accurately at certain location, you may need to have a very refined mesh, and in that case you may need some high performance computing system. The SolidWorks may not be very much useful in that case. And definitely the multi-physics scenario, so the normal thermal and structural analysis is available in SolidWorks, but if you want to go through other kind of analysis, like the people who are working in the civil structure or the geomechanics problem, or the people who are working in the electromagnetics problem, like you are developing certain kinds of watch where the electromagnetic or the fans, so where the electromagnetic coupling is there, or certain kind of scenario where your impact and cross is there. So those are highly nonlinear kind of scenario where lot many contacts are there, and the material can deform in a significant way. So in that case, it is really difficult to capture the accurate behavior through SolidWorks simulation. Even for certain kind of manufacturing process, like the metal forming or stamping process, or the material where because of loading your material can have damage or failure, or like advanced composite scenario where you're having multiple composite layer and they're having damage included in the different layer of the interfaces, and they are having a highly anisotropic kind of material behaviors. In those cases, the SolidWorks simulation may not be useful at this phase. And even if you want to define a user-defined subroutine, or if you want to apply certain kind of Python scripting to automate your model, so in that case, Abaqus is real handy. So SolidWorks also in a way provide certain kind of feature, like it is also having a scripting scenario to VVA, but that is not really very sophisticated for the advanced kind of simulation process. Now if you want to extend your simulation capability for all this scenario, you can basically use Abaqus CA, and these are the certain example where these kind of problems are being solved in through Abaqus CA. Every nonlinear analysis tool has its own limit and the amount of complexity it can successfully resolve. And SOLIDWORKS simulation premiums start to reach its limits as we include several no penetration contact interaction in an nonlinear analysis. And SIGIN simulation premium users already familiar with the occasional warning message that indicate that the software is struggling with convergence at each step. So Simulia Abaqus has more robust contact solver, which allows us to resolve this contact interaction more effectively, and has richer control over some of the contact interaction option. Also, there are also usability difference in this situation. So SolidWorks simulation require explicit definition of contact pair between faces that might come into contact, which means that each potential interaction between the two surfaces has to be defined as a feature. But similarly, Abaqus offers a function called general contact, that will scan the model at its chip and automatically find the contacting surface, and it will automatically determine the contact algorithm as well. So we recently completed an analysis project that featured contact interaction between a scan model of a portion of the human body and therapeutic device, and in all there is like 50,000 different unique faces interacting with each other. The contact capability of Simulia Abaqus was a huge asset in resolving a very accurate solution to the problem, but additionally identifying the contact feature for each of those faces would not have been logically feasible in SOLIDWORKS, because we need to have defined all this contacting surface manually. And definitely in all this simulation you see, like the materials are really not a metallic material. So this is like a front loading washing machine. So where you're having fluid and structure is basically interacting with each other. And this scenario, like when you are shaping your foot on the ground, so you are having the material like the human tissue, bone, and those are kind of very complex materials. So to capture their behavior accurately, it is very difficult. Even they are having huge number of content. So Abaqus is really handy. And even for the crash scenarios, if you see here the crash scenario of a car, so you are having thousands of parts together. So it's really impossible to define all these contacts manually. So SolidWorks assume that they are basically kind of bonded contact or the no separation contact, but that really does not capture the accurate scenario. So here Abaqus robust contact behavior really helps a lot. And even in the post buckling scenario, like when you are crashing a can, so once the buckling scenario is happening, so what will be the post buckling response and how when it will be stabilized. So those kind of simulation is really difficult to predict through a SolidWorks simulation. And certain multi-physics simulation, like say fluid structure interaction, which is like butterfly valve, when your fluid is flowing through the valve, and how the pressure is changing when you are opening the valve and how the flow is happening. And even for the heat exchanger, when it is carrying the hot and cold fluid and they are mixing together, and how the thermal the heat transfer is happening between the different kind of fluid. Or even when you are dropping a water can which is having a tertiary filled fluid, so in that case you can see like how the real world and the simulation basically collide with each other. And certain kind of scenario where you're having like say fluid and structure interacting with each other. So this is one of the model where we are using coupled Eulerian Lagrangian method, and where so this is a hydroplaning process. So the water is basically modeled to the Eulerian domain, and the actuator is modeled to the Lagrangian elements. And this is one of the cases like when you are having paste coming through a tube. So in that case, the paste really behave in a viscous fluid fashion, right? So to model those kind of scenario, you can use either CL technique with the uh, 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 with the with the accurate material behavior of the paste. And this is one of the scenario, like we know that SolidWorks is having a thermal analysis capability, but there are certain kind of thermal stress analysis where your heat generation is happened because of the friction. So like if you are pressing a brake pad on the rotor, so because of the friction there will be heat generation. So these are certain kind of complex scenario where the thermal structural interface is there, but it is really difficult to capture all those scenarios through the simple SolidWorks simulation capability. And even certain scenario, like when you are passing certain current through in the spot oil scenario, you are passing a current through the uh, uh, sheet metal, and because of the contact pressure and the electrical flow and the resistance, there will be heat generation, and the sheet metal will be fused together at that location. So these kind of resistance spot oiling scenario is very difficult to simulate with the SolidWorks simulation, where Abaqus can really come handy, and it can really define the um, uh, a better parameter for getting a better simulation strategy. And this is like the material model calibration, and we know like the main challenge for a expert analyst is that getting the actual material model. So eyesight is having something called optimization. So and the data matching component, where from the real world you can have a experimental data, and you can try to capture the uh, the same experimental system in Abaqus CAE, and with the result you can do a reverse calculation and find out what is the exact material property to get that kind of response. So you can really do a reverse calculation without knowing much about the composition of the material, and you can get the exact material parameters. And this is one scenario where you want to capture the fracture mechanics. So it's like extended finite element method. This is not a mesh sensitive approach. It is actually a mesh insensitive approach. So when you are having a backhoe, and in the crane, when you are having repeated number of loading, or even if you are applying huge amount of loading, the fracture can propagate in a certain fashion. So you can use the XFEM technology to calculate to capture that kind of fracture propagation scenario, as you know what will be the life of that particular kind of um, tooths. And this is one of the case where you are having a needle penetration into the soft tissue. So soft tissue actually behave in a very different way. So you are modeling the soft tissue using the CL technique, and so the added bonus is that the algorithm is for mapping the material orientation for the anisotropic material. So the soft tissue will be having an isotopic material. So we are adding that on. Even it will be having a hyperelastic kind of response as well. Like it can have a huge deformation. So for the life science simulation of an injection into a soft tissue is basically shown here. So those kind of complex scenario can be developed in the Abaqus simulation process as well. And this is one of the cases like where your contact is basically kind of edge to edge contact, or say surface to edge contact. So in this scenario, it's really difficult to capture these kind of contacting phenomena in SOLIDWORKS. You have to either assume bonded contact. So Abaqus really helps a lot to solve this kind of problem at a very great ease. And eyesight is basically, as I told you, like this kind of complex eyesight workflow you can develop from certain department. You can combine all these components together in the eyesight workflow so that you can have a whole automation process. And Simulia Tosca structure optimization is basically having four different optimization strategy. One is like topology optimization. There is like sizing optimization, where you basically uh, try to basically optimize the thickness of sheet metal, and the shape optimization, where you want to have a local deformation so that the stress can be reduced to get a further better fatigue life, or the better stress. And even the structural bead optimization, where you want to have a local deformation, the local bead for the sheet metal. And this is the thing what I was saying about the efficient. So this is actually a scenario which is developed by Hyundai Motor. So they really didn't believe that this could happen at the initial phase when this efficient was able to predict the fatigue life calculation very accurately. So the scenario is that they're having a knuckle, and and they have applied a repeated loading of low cycle loading, and they found a location where the fracture is happening at this location. And then what they have done is that they have applied the high amplitude cycle, and there also they are seeing that the failure is happening almost at the same position. But then what they have done is that they have changed the loading with a combination of high and the low cycle amplitude. Okay, and if you see here, the location of the fatigue, or the location of the fatigue failure, is completely changed to a different location. So the history of the loading plays a big role in the fatigue calculation. And not only the history, even the manufacturing stress, like say residual stress, or if you're doing some metal forming procedure, there will be some initial residual stress that also plays a big role in finding the optimum fatigue life of a product. And generally with the normal fatigue life calculation, we neglect all those things. So here FESIP can take into account all those things, and it can give really a very detailed understanding of the fatigue life, and can calculate accurately the fatigue life of a product. Now Now, this actually brings us to the end of the talk, and there are basically two main things we are doing at the Simulia to respond to the simulation revolution. So we are basically constructing the best-in-class portfolio of technology that is available today in our traditional product suite, and we are also building the technology into a 3D experience platform, a platform which is built for all users through an enterprise to enable simulation to drive innovation. So in this webinar, I have focused on the portfolio, Simulia portfolio, and we'll use that technology to power the platform, but you don't have to wait. It is available today for all users through our extended packaging strategy. And I hope I have convinced you that we have a vested interest in helping continue the simulation success we have achieved so far, and that we remains as committed as ever to maintaining and enhancing our industry-leading simulation technology in Abaqus, ICED, FE7 Tosca. Also, we are focused on improving the openness of our product to help you leverage all of our simulation tools, and we can provide access to this technology through Abaqus extended tokens. So you need not to buy a separate set of tokens. With the same tokens, you can get access to all these things. And with that, I want to thank you for your attention, for attending our webinar, and for being our customer. Thank you very much.